Hey everyone, get ready because we're diving into the world of quantum computers and AI today.
Really fascinating stuff.
It really is. We're looking at a research paper called uh, Completely Quantum Neural Networks.
Kitschy.
Right. So we're talking about scientists building a neural network completely inside a quantum computer.
Yeah, and they're using this thing called a quantum annealer. It's like, a really powerful optimization tool.
To what? Find the best solution to a problem?
Exactly. And in this case, the problem is how to train AI, which is a pretty big deal.
So this is kind of the next level of AI.
You could say that it's pushing the boundaries of what we thought was possible.
Okay, so for those of us who don't have PhDs in quantum physics, what exactly is a neural network?
How does it actually learn?
Yeah, break it down for us.
Well, think of it like a kind of like a digital brain,
Okay.
a network of interconnected points.
Yeah.
And it can learn to recognize patterns.
Like facial recognition software?
Yeah, exactly. Or those language translation apps, or even self-driving cars.
So that's all powered by neural networks.
Pretty much. And traditionally, we've been training these networks using classical computers, right?
Right.
Which work with bits, zeros and ones.
Got it.
But quantum computers are different.
How so?
They use these things called qubits. And a qubit can be a 0, a 1, or both at the same time.
Wait, both at the same time? How is that even possible?
That's the beauty of quantum mechanics. It's like, imagine being able to explore every path in a maze simultaneously.
Instead of going down one path at a time.
Exactly. And that's what makes quantum computing so powerful. It can analyze tons of data all at once.
So instead of going step by step, it's like it can see the whole picture immediately.
Yeah, you got it.
Wow. So is that what they're doing with this completely quantum neural network?
Yeah, they're trying to build and train a network entirely in this quantum realm.
Using these special properties of quantum mechanics to speed things up.
Exactly. And hopefully find solutions that regular computers might miss.
That's incredible. So how do they actually go about building this thing? So how did they actually build this quantum neural network? It sounds really complicated.
Oh, it is. It's incredibly complex, but that's what makes it so groundbreaking, right? They
Yeah.
had to figure out how to represent the neural network's information. Things like how strong the connections are in the network,
Yeah.
in a way that this quantum annealer could actually understand.
Right, because it's like a whole different language, right?
Exactly. It's like translating, I don't know, the complex math equation into some language that only this quantum computer can understand.
So how do they even test it? Like what kind of problems can this quantum neural network solve?
Well, they tested it on a few different data sets. One of them was actually data from the Large Hadron Collider.
Oh, wow, the particle accelerator.
Yeah, exactly. The one that's been in the news a lot.
Yeah.
They wanted to see if this quantum neural network could find hidden patterns in the data that might have been missed by more traditional methods.
So we're talking about using quantum AI to unlock the secrets of the universe.
Yeah.
Potentially.
Potentially, yeah. And the results were actually really promising. They found that this quantum neural network, the one they built, it could achieve accuracy comparable to, and in some cases, even better than traditional methods.
Really?
Yeah.
So it's not just faster, it might actually be better at finding solutions.
That's the exciting part. But there's a catch. One of the biggest challenges right now is that quantum computers are still, they're relatively small.
Okay.
They only have a limited number of qubits, those quantum bits we were talking about earlier.
Yeah.
And this limits how complex the problems can be that they can handle. It's like, imagine trying to run, I don't know, the latest video game on a really old computer. It might work, but it's not going to be pretty, and
Right.
it'll be slow.
So for now, we're limited to smaller quantum neural networks.
For now, yeah. But the field is, it's advancing so rapidly. As quantum computers become more powerful with more qubits and better connectivity, we'll be able to tackle even, bigger and more complex problems.
So this all sounds super promising, but what does it actually mean for the average person? Why should we care about quantum neural networks?
That's the key question, right?
Yeah.
Right now, it's still early days, obviously, but the potential applications are huge. Imagine a world where we could develop life-saving drugs in, a fraction of the time that it takes now, or create ultra-efficient renewable energy sources, or even design materials with properties that, we can only dream of today.
So we're talking about revolutionizing entire industries potentially.
Absolutely. And while those applications might seem, a bit far off,
Yeah.
There are more immediate areas where quantum neural networks could have a big impact. Take financial modeling, for example. Imagine being able to predict market trends with much higher accuracy or optimize investment portfolios in a way that were just impossible before.
That would be, I mean, for investors, that would be a game changer.
Exactly. Or consider personalized medicine. With quantum AI, we might be able to analyze an individual's genetic makeup and develop treatments that are specifically tailored to their needs.
Wow. So we're talking about like truly personalized healthcare, like on a level we've never seen before.
That's the potential of this technology. It's not just about making things faster, it's about solving problems that, we previously thought were unsolvable.
So even though we might not all understand like the ins and outs of quantum mechanics or neural networks or whatever,
Right.
it's clear that this technology has the potential to affect like all of our lives in some pretty significant ways.
Precisely. And that's why it's so important to, stay informed and engaged with these advancements, even if they seem a little bit complex, at first glance.
So we've talked about the potential, but are there any downsides or risks we should be thinking about?
Of course, yeah. With any powerful technology, there are always potential downsides. One of the big ones with quantum computing is the sheer complexity of, actually building and maintaining these machines.
Right.
They require really specialized equipment, extremely controlled environments, and, a high level of expertise to operate. This means that, at least for now, access to this technology is likely going to be limited to,
Yeah.
like well-funded research institutions and large corporations.
So there's a risk that like the benefits of quantum AI, they might not be evenly distributed.
Yeah, that's a valid concern. It's something that, we need to be mindful of as this technology develops. We need to make sure that access to quantum computing power is,
Available.
democratized, yeah.
Yeah.
And that its benefits are shared widely, not just, concentrated in the hands of a few.
That's a really good point. It's not just about the technology. It's about like how it's developed and who benefits from it.
Exactly. And another potential challenge is we need new algorithms, new programming languages, that are specifically designed for these quantum computers. Traditional programming methods, they aren't efficient or effective when you're dealing with quantum mechanics.
Right.
It's a whole different ballgame. So this means we need to train a whole new generation of,
Programmer.
quantum programmers and developers. Yeah.
Yeah, it sounds like we're talking about like a whole new paradigm of computing.
Yeah, absolutely.
One that requires like new ways of thinking, new skills, new approaches to problem solving.
It's a paradigm shift, like in the truest sense of the word. And with any paradigm shift, there are going to be bumps in the road. But, I'm optimistic that we can overcome these challenges and actually harness the power of quantum computing to,
Do some good.
for the betterment of humanity. Yeah.
That's a really important point to make, that the potential benefits are so vast that it's worth kind of grappling with all these challenges.
Precisely. Yeah. It's like, exploring a new frontier.
Yeah.
There will be unknowns, there will be risks, but there will also be these incredible discoveries and advancements that could,
Change the world.
transform our world in ways we can only begin to imagine.
It's a journey worth taking,
Yeah.
even if it's a little, bumpy along the way.
Exactly. And it's a journey that, we're just starting to embark on.
Yeah.
The research we've been discussing today, on these completely quantum neural networks.
Yep.
It's really just a glimpse into what might be possible in the future. Who knows what breakthroughs are waiting for us?
It really does feel like we're on the verge of something incredible here, doesn't it?
It does. And the most exciting part is we're just getting started, right? This research, these completely quantum neural networks, it's really just a tiny glimpse into what might be possible.
So where do we go from here? Like, what's the next big thing for quantum AI?
That's a great question.
Mhm.
One really interesting area of research is looking at different types of quantum computers and how they can be used for these AI applications. You see, quantum annealers, like the ones they use in this paper, they're really good at optimization problems.
Right.
But there are other types of quantum computers out there, like gate-based quantum computers, for example.
Okay.
And those might be, potentially even more powerful and more versatile, for certain tasks.
So it's like having different tools for different jobs. You wouldn't use a hammer to, tighten a screw.
Exactly. Each type of quantum computer has, its own strengths and weaknesses.
Right.
And finding the right tool for the job, that's going to be really crucial, for unlocking the full potential of this whole quantum AI thing.
This has been a fascinating look at this whole world of quantum computers and AI, it seems like this technology has the potential to, really change everything.
It really does. And it's not just about the technology itself, right? It's also about the ethical considerations. What are the societal impacts? How do we make sure that we're developing and using this technology responsibly?
That's a good point. So it's not just about, building the most powerful computer. It's about using it for good.
Exactly. It's about benefiting all of humankind, right?
Well, that about wraps up our deep dive into completely quantum neural networks. Hmm. This has been, I don't know about you, but I'm definitely feeling a little quantum entangled right now.
Me too. It's a lot to process, but it's pretty exciting stuff.
It is. And for our listeners, if you're as fascinated by this as we are, I mean, we encourage you to go out there and do some more exploring on your own.
There's a ton of information out there.
There really is.
And remember, the future of quantum AI, it isn't something that just happens to us, right?
Right.
It's something that we are all creating together through our curiosity, through our ingenuity, and, the shared desire to solve some of the world's biggest challenges.
That's a great point. Well, until next time, keep asking those questions, keep exploring, and keep diving deep.